Alrighty, so welcome again to this Hubble in Action webinar. My name is Marco Salinas, and I'm really happy to be here with you again, talking more about energy efficiency and how can you improve your designs and how can we empower you to optimize your designs with the use of artificial intelligence and with Hubble. In the case, so first of all, thank you to the marketing team for doing an amazing work promoting our webinars. And just in the case you are new to Hubble, Hubble is a tool that was developed in-house at Suho for the last perhaps 1 year, and we have been conducting some research on how can we add value to design builders and residential builders. We're really excited to reach perhaps that end of our user research, and we will be rolling out in stages Hubble in July. So in the case you haven't signed up for our waiting list, feel free just to do it at hubble.sh, and we'll be contacting you. Today we're going to be demoing Hubble using an 8-star house. Actually, it's an 8.3-star house. And I'm really happy to have here Ruth Nordstrom, one of the masterminds behind the construction of this house. And we'll be talking with her in a few seconds. And then we also got Pia Daniels, and she will be using the 8-star house inside Hubble. And we will look and actually how actually that comes up. So thank you again for joining. Hubble tries to reduce the complexity of energy efficiency and provide more options, letting you have a better material selection. So again, thank you for joining. And let me just share really quick, in the case you aren't familiarized with Hubble, what are we trying to do? Let me share one quick slide, and we will continue really quick with Ruth. So let me just go to this one. At the end of the day, what we're trying to do with Hubble is to reduce that complexity of energy efficiency, and this will empower you to optimize your designs, but at the same time will empower you to start connecting better with your clients and improve that customer experience. Usually energy efficiency is something that happens at the end, and usually is a really obscure science just for experts. So what we're trying to do is to put it at the front end, so you can discuss these topics with your clients, and you can start conveying correctly what are the huge benefits of better material selection and a better layout. At the end of the day, the knowing or having an estimate about energy efficiency will streamline your process, because you will mitigate that risk of not fitting your design into compliance, which is amazing, and that will generate a lot of savings in your construction process. And at the end of the day, and perhaps that's the reason we are here, all of us, we will be contributing to fight positively climate change, which is perhaps one of the most important things. And we're trying to do things better by reducing and by using technology that now is available to everyone. So I'm really excited. Again, we will have amazing features coming up in Hubble in July. We are adding double stories and optimizations and some visualizations on how can you improve your designs, and that will be coming up in July. And in the meantime, let me just welcome Ruth and Pia. Thank you, Pia, and thank you, Ruth, for joining today our webinar. Ruth, perhaps really quick with you, what's perhaps from a personal perspective, what's the thing that you like the most, or about the 8-star house, or I mean, perhaps just personally and in terms of energy efficiency?
Okay, so in terms of the 8-star house, what I like about that house is it really challenged the fact that we could only work with a lot of south on that site because it had northern boundary walls, which is very unique. So it was quite challenging to firstly design the site with the council encumbrances in terms of conceptual massing from the word go. But once we got into it and started manipulating the site, we found that we could use courtyards on the north to really bring up that star rating, and working with that glazing to wall ratio was highly important on that, as well as indicating things like shading and the size of windows. So personally, for me, using something like Hubble in terms of what we do as designers, and even during our engagement and feasibility stage, even before maybe signing up clients, we can go up to site, say like what we did on the 8-star house, and work out what is the best form for that site even before going into planning, which really empowers owners to even approach councils before buying land or so forth. So it's a hugely powerful tool, and hopefully a game changer. It certainly has been over the last year for me, having early access to it. So thank you, Marco. Tried and tested and very confident in this. So.
Thank you, Ruth. We previously ran the 8-star house in Hubble, and actually came up with like 7 stars or 7 point something, and what actually is 8.3. And I know that you did something interesting in the design of the 8-star house. Can you perhaps talk a little bit more about this?
Yes. So knowing that First Rate 5 really prefers thermal mass, what I wanted to do is analyse that building based on the external layer of the building. So this building actually has a little bit of importance because it had an airtightness strategy on it, and part of that is actually making sure that the fibre cement outer shell is the airtight part. So in Hubble, what I did was actually analyse that without the thermal mass on the inside, so that I knew that I could optimise that shell before putting in the preferred materials from First Rate 5. So the advantage of that is that even modelling that house as the fibre cement exterior means that maybe I could get it up to 7 stars, and then working with the thermal mass on the inside, using my experience and knowledge on what works in these programs and what works in real life in terms of thermal mass, and that northern gain meant that we could strategically place that thermal mass to even optimise that building even further. So it gave us a really quick benchmark, super simple, in terms of how to design a building and then take it to the next level, so that we're reducing the demand on the grid firstly, and then we can look at things like solar panels and so forth later. So we're after a home that essentially performs at least 2 times better than a 6-star house, or at least can give us a much more holistic approach. So that's why we use that.
Thank you, Ruth. And just in case you want to hear more about the 8-star home, I included really quick below the website, so you can just go and check out basically what it's about. Thank you, Ruth, for let me just add you to here. Thank you, Ruth, for joining. It is amazing the work that you do, and obviously not talking just from my perspective, of the entire Hubble and Sugo perspective. We really feel proud about all the constructions that we are doing with the use of technology and different research projects. So we got the 8.3 stars, and then not only that, but we also we're working on a 10-star house that will be ready for open to public in September. Is that right?
It's actually going to be open sooner. So, September 2nd is the official public opening. But before that, we go into a heavy couple of months of data monitoring and really looking at the performance of the building and comparing what the NatHERS certified model is compared to real life, which is super valuable. Also because we haven't had a building this airtight in Australia before at 10 stars. So it's quite unique.
When are you planning?
Hopefully be starting next week.
when are you planning to finalize the 8-star house, or when it's going to be completed?
Well, it's currently on the market, so it should be finished hopefully in about 6 weeks. All the internal linings in. I did a virtual tour the other day, which is something that we're doing in a lot of our houses now to help people visualise what they're getting, but also integrate services and so forth. So they can have a look at that as well.
Awesome. Something that I forgot to mention is that my virtual background is about the 8-star house. So actually, we're looking at the 8-star house. We're looking at the render, so you can see how amazing it is. Well, thank you very much for joining, Ruth. I would want to switch to Pia. We're going to start doing the demo on Hubble and how this floor plan actually looks in Hubble. Right. So thank you very much, Ruth, and talk to you soon.
Thank you.
All right, Pia.
Hi, Marco. How are you?
Sorry.
I'm going to start by going through the 8-star house in Hubble. So we just need to share my screen so that we can show people what's going on. Sorry, Marco. Yeah, thank you. Okay, so today we're just going to run through this 8-star house in Hubble. As Ruth mentioned, there are some features in the NATA's software, like the thermal mass that Hubble currently hasn't picked up, which are some things that we're working through and will be scheduled for later releases. I will currently be using the first almost not for release version of Hubble. So while I'm doing this, keep in mind that new features have been added to this already. So today I'm basically showing us how to take the information from the plans and get that information into Hubble. So we're looking at this 8-star house, which is located in South Australia. So to start with, the first thing I need is the location of the building, as that picks up all of the weather data and everything else that comes with that. So moving over to Hubble, this is what Hubble looks like. It's a very simple tool to use, and so we're just going to pick up as much information as is needed to predict the performance of the building. So I'm going to start with the location of the building. So it's 11 Glen Stewart Road. As you can see, this is a map powered by Google, so we're looking at some of the addresses already being picked up. This map here allows you as well to drag around the address. So if the location can't be found, such as new housing developments, you can actually drop a pin to the nearest point and then move the map around to find the location. Moving on from the address, which will pick up all the critical data. We're then selecting the materials, all the critical materials for the building. So one of the things that Ruth mentioned is the thermal mass, and one way that they have done that in the design, just flip back to the plans quickly. So just to show you the floor plan, as Ruth mentioned, this building is built along the northern boundary. So this is the northern boundary up here, and as you can see, it means it's limited the amount of glazing in the main building. But they've also maximised on the thermal mass by using reverse brick veneer through some of the areas of the building. Currently, we are adding that to Hubble. So in the meantime, I'm going to click or use the closest material that allows for some mass as well as being close, allows for insulation. So I'm going to select brick veneer in this instance. Once I've selected my main wall construction, I'm then just looking at key insulation materials. So they were using a total of 2.7, so I'm going to pick the closest material that we have available, which is 2.5. the roof colour, which was dark through their runs. You can see there's varying different colour options to select from. Ceiling insulation, they were actually had close to R7 in the ceiling, between layers of insulation at the ceiling and then sort of roof. So they had R6 at the ceiling, which is also being added, but I'll just take the closest that we have, and there's no, as this is a single story house, there's no suspended floor in the building, and this was also a concrete slab on ground. So I'll just go back to the plans just so that we can see some of this information. Sorry. So if we pull over to a section through the house, you can see the building is a concrete slab on ground. There's the insulation, which is in the specifications, and the ceiling insulation here. So you can see the large ceiling bats and then bats further up here. So there's no floor insulation, and then we're just going to put some foil, which would have added insulation, which is being, as again mentioned, added to the system at roof level. So once we've got that information, we're moving on to the design of the building. So we're just after key design arrangements of what the building looks like. So total floor area, total wall area, the most predominant eave. So when a lot of houses have varying eaves or pergolas or verandas to the building, we're just after the most predominant one that works around the building. We're also looking at building ceiling, roof ventilation, and ceiling fans. So if we pull the plans back up, I have prepared this earlier. So the floor area and the perimeter is taken to, measurements are taken to the inside of the external walls. We're looking at the amount of heat flow in and out of the building that is affecting the internal air spaces. So that's why it's taken to the inside of the external walls. You don't have to worry about the internal walls, like the area that's taken up by that, because we're only after, this is an estimate, which is, it's just a prediction. So we want the process to be quick and simple and not take up too much time. And we're also including the garage in this measurement. So you're taking in the garage floor area as well. So 151.7 square metres. Total wall area, back to our plans. So here we're looking at the perimeter of the building multiplied by the ceiling height. So normally we would take the ceiling height as just being the height of the walls, the external walls, if it's a flat ceiling. In this instance, we've got rake ceilings through this building, so we're looking for an average ceiling height. Now we've got lower walls and one side higher on the other. We've also got small bits of wall running along the northern side of the building which have windows in them to add northern light. So we're going to just take an average ceiling height here to get the overall average out the total wall area. So we're looking at the perimeter measurement, which is 69.51 multiplied by the ceiling height, which gives us a total perimeter of 270.4. We're looking for the eave. Now this building has a pergola running along the eastern side of the building, has a small shade over some of the western windows, no shading along the south, which is because it's not necessarily needed. And then the really only northern window here has vertical shading to it, which can be seen here in one of the perspective. So we can see some vertical shading to the northern window into the courtyard here, but we can also see there's no shading on these other courtyard windows. So when we're doing this, we're not going to enter an eave depth in here because there is not really an average eave, and we'll just add shading individually afterwards to the windows. Now this building is sealed tight, as Ruth mentioned. There is no roof ventilation in this building, but there are ceiling fans which we can find on the electrical plan. So as we can see here, we've got ceiling fans in the bedrooms as well as in the main living area. So back to Hubble, and we'll select that as well. So next and last thing is the data we need for the windows. Now we're after the total area of windows for each orientation, whether they're shaded, and then the U value and solar heat gain coefficient. So taking the total window area, this information would be taken from the plans. You'd have to do the calculations to add that up, or if the software you're working with gives you that information, which is a lot quicker, you can take out that information for each orientation. So if after manually calculating it, you'd have to manually add it all up, unfortunately. So for the north, we're looking at 15.8, and the upper level windows don't have shading on it, only one window does, so we're not going to shade these windows. The east has a total of 8.4 meters squared, and we know that that had the pergola. The south has a total of 5.1 meters squared without shading, and the west was 11.3, and we know that that was also a split large window in the courtyard isn't shaded, but some of the smaller windows at the front are shaded, so we're going to leave this as unshaded because the larger window to the courtyard is the predominant area which is not shaded currently. And then the last thing we need are the window values. So we can do this in one of two ways. We can drag this slider to a specification, or we can enter in the window specifications that are being used. So again, here we're just looking for the most predominant window that's being used through the building. So these ones, a U value of 3.6 and a solar heat gain coefficient of 0.47. So that's all the data that's entered. That's all the data that we need for the assessment. And once that's done, we can just click on Get Rating. And the results show up here for the building. So with some of the data missing, this has actually given us a very close prediction of what the building will perform at, which is nice to see. This is sort of the area that we're looking at, and once we start refining Hubble with correct values, we'll come in closer as well. So Hubble's now showing us that this building is performing at about an 8.3 star rating. The energy saving is approximately 30% on the minimum standard house built across Australia, approximately 48% more comfortable than the minimum standard, and potential savings across a 10-year period are about $14,500. So that's quite a significant saving that we're looking at there. And so that's the simple manner in which we can enter data into Hubble. It only takes a few minutes, and it gives us a very close prediction of the performance of the buildings.
That's amazing, Pia, and actually it's amazing to see that now with the correct details, we're getting closer to actually that 8.3 stars. The actual result, the NADES result actually was 8.3 stars as well. So as you can see, actually we're trying to reduce that gap, on our estimation. For those people that are quite familiarized with the NADES process, we are not running a simulation. This is perhaps just trying to guess what's the energy efficiency of a house, and this is with the use of artificial intelligence and big data. So it's amazing to see actually how close it's getting. And as you were able to see, not only we are trying to show the star rating, but in a similar way, we're trying to show what's the benefit and what's the impact of that star rating. So you can convey correctly to your clients what's the trade-off of using better materials, of using a better layout or a more energy efficiency layout, or what are the implications of having different orientations of the windows in a more tangible way that actually you can convey. You can start having those conversations at the beginning of your project, increasing even the trust with your clients, which is a big thing with builders. Back to you, Pia. I don't know if you would like to add something more, or perhaps now that we have the design, I don't know, perhaps if you can show like different specs, like how quickly we can start having those conversations about, I don't know, perhaps the different type of insulation in the ceiling, or what will happen if we improve the glazing, or reduce the glazing actually perhaps to single glaze, just to see perhaps what will be the performance of the house, or what else could be with the yes, or perhaps select a different type of wall. Okay, so I'm back to you.
Yes, so I mean, this building has been high spec to achieve a high performance rating. We're looking to, as Marco and Ruth have both mentioned, we're trying to reduce greenhouse gas emissions and make living more sustainable. So this building has, with the restrictions of the site layout, it has been spec'd fairly highly to achieve the outcomes desired. So if we start taking some of these specifications back again to some of the specifications that are often used in standard houses, we can start. So I've changed the windows back to what would be a single glazed aluminium window, and you can see that this rating has already come down by over a star in the performance of the building. And if we start reducing insulation to some of the more standard levels of insulation, we can see the performance of this building slowly coming down. So this does show something like adding floor insulation. So insulated concrete slabs that have polystyrene laid with the concrete over the top. You can see that as actually improving the performance of the building versus having a non-insulated concrete slab. So we can start seeing how the building performs with the change in those materials and the change in the specification. If we reduce, say, Western windows, yeah, we can see that it hasn't quite altered it that much, but it has brought the rating down slightly. So you can start fiddling around with the windows to show how the building is performing. You can increase window area. So we don't want to be increasing window area too much, because windows are, unless they're highly spec'd windows, they're sort of almost like holes in the walls where a lot of heat loss happens. But we can see when windows are orientated in the right direction, so with north facing windows, we can see that rating is starting to come back up again. So once you've got a design, you can then start changing around how the design arrangement looks with either the actual design of the building or the specification, to start seeing those differences. And it changes. So with this new specification and window orientation, you can see the operational savings have been reduced down to 9,000, potentially 9,000, where we had it at 14,500 before. So you can start seeing those differences in how a building will perform, and start showing and quantifying, the investment, say, in double glazing for the potential cost savings of running the building over a period of time. And obviously, as Ruth mentioned previously as well, adding things like solar panels would offset these costs even further. So one of the key features of Hubble is that you can actually save ratings. So you can click Save Design. So you can save different variations of the design to show the differences between, say, single glazing versus double glazing, higher insulation levels, or different arrangements of windows. So you can start having those conversations between the client and the designer, or clients and people specifying, window specifiers or different things like that. Back to you, Marco.
Thank you, Pia. So yes, it's amazing, like how can with this information then we can empower the building designers to go back to the client and start having those conversations. We will provide in the upcoming versions the breakdown on from where are we getting these numbers and the breakdown. So in order to provide a little bit of more transparency, and something that is quite interesting is that it also will involve moving, perhaps, or fiddling with the occupant behavior, because that could be quite different if it's a retired couple from a young couple or a big family. So those parameters or those variables, we're going to be adding them into Hubble. So then you can start having those conversations with your clients in terms of and narrow down the benefit just to a more specific scenario that will fit even better. So just to finalize this, Pia, perhaps if you can explain what is that chart that is showing below that one, really quick.
So the predicted heating and cooling load that we've got here is with the current building code. There are when you get a NADA's assessment, they're also looking for specific heating and cooling load caps. So a building has to fall, not only does it need to achieve 6 stars, it also has to achieve a certain level of heating performance and cooling performance. So you can't have a house that's perfectly comfortable in winter, but horribly warm in summer. So these predicted heating and cooling loads are showing how the building is likely to perform. So anything sitting up in the red is not ideal. Anything sitting down in the green area means it's quite low, which is good performance, but you want to have both your heating and cooling loads averaged out. You don't want one down in the green and then one up in the red, because that means you've got a house that's comfortable in one season and very uncomfortable in another season. So currently this house would need to start looking at working on that cooling load, whether it be shading the northern windows to start reducing that cooling load, to start bringing that marker back down sort of into the average area, up straight, or even down into the green area.
Thank you, Pia. Well, with this, we are reaching almost the end of our webinar. So thank you again, everyone, for joining. It has been really good again to be here talking about Hubble and how are we helping you, empower you to come up with better designs and communicate better with your customers and improve your processes. So in the case you have any question, please feel free just to send it through. Perhaps we reach that point in time where it's the QA. In any question, please send it through. Otherwise, with this, I will be saying goodbye to Pia, and I can see that Ruth is still around, so I'm gonna say really quick again bye to Ruth. Thank you for joining both. Thank you.
Thank you.
Demo. Actually, it's quite amazing to see that we are getting that close. And let me check. Yep, I cannot see any question. But well, in the case you have any question or you would like to connect, please feel free just to go with to info@sugo.com.au, or just contact us through our website, or join the waiting list at Hubble, or feel free to connect on LinkedIn as well. More than happy to see you there. Well, we reached the end of the webinar. Thank you, Ruth, and thank you, Pia, again. And with this, I will be saying goodbye.
Welcome. Thank you.
Thank you. See ya.